The exterior angle theorem. What did the exterior angle theorem say?
It's equal to the two opposite interior.
They were called the remote interior. So here we go. Let's make a triangle. And then just to show you, demonstrate. All right, let's say what?
It's a garbage truck.
Yeah, they're fixing. If you want, Taya, will you shut the door for me or whoever over there? All right, so we'll call this A, we'll call this B, and we'll call this angle number 1. All right, so what is true about the relationship between angle 1 and A and B? Go ahead. Yeah, so listen to me. Angle 1 is equal to angle A plus angle B. Does that make sense? Right, we proved that. All right, so now here, look how complicated this is. All right, so the exterior angle inequality theorem, the measure of the exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. Does that make any sense at all to anybody? Right? Of course, that's true. All right. Why do I say, of course, that's true? If A plus B equals angle 1, then angle 1 has to be greater than either one of those. All right. We say the sum is always greater than the what? Than its parts. That's exactly right. The sum is greater than the parts. So angle 1 is greater than angle A. Angle 1 is greater than angle B. All right. Now we can also extend this out this way. All right. And then if I call this, for example, angle number 2, then we could say that this angle number 3 is greater than what? B and 2. That's it. All right. So again, enjoy the simplicity of this section and actually this chapter. All right. Now, as I always say, I think things are easy and obvious, right? But they're not always easy and obvious for you. All right. I'm trying to show you that. I'm trying to show you it's obvious. So if you're sitting there going, I don't have any idea what the crazy guy is saying, it would be nice if you raised your hand, all right, because you're heading to high school, and when you don't know something, it'd be nice for you to have the courage to raise your hand and say, what's up with that? All right, I don't see it. All right, especially as you progress in math. All right, it gets more difficult. It looks more difficult, trust me, but it really isn't. All right, the advanced math is just understanding some principles. All right, and the basics always apply to the complicated. All right, the symbolism is what makes it look difficult. All right, so this is just, to me, basic, easy information. All right, so let's see if there's anything else. All right, so over here, all right, one basic rule. All right, so we'll start with number 1. We want to try to figure out the measures that are less than angle 1. All right, now here's where people always have trouble. Can I say anything about, I'm going to blow this up a little bit. Can I say anything about 2's relationship to 1?
Yeah.
I can say nothing about it. They might be 90 degrees. One might be 91 and the other might be what? 89. You can't look at them and say, well, one's an acute angle, one's obtuse, therefore it's greater. All right, you can't say that. There is only one thing you can say. The exterior angle is always greater than the remote interior angles. That's what you can say. All right. Now, down here, this right here is a little bit more complicated. All right. But we're going to start out with the easy. All right. Now, measures that are less than angle 1 are what? Angle 3 and angle 4. You can't say angle 5. Right? There's no relationship there. All right. There's nothing specific about the exterior angle and the exterior angle. Although angle 5 looks bigger than angle 1, we can't say that for certain. All right. Is everybody okay with that? All right. Come on, join in now. Number 2. Measure greater than angle 3. 1 and angle 5. I'm telling you, it's really that easy. It's really that easy. All right, do I know the relationship between angle 2 and angle 3? There is a relationship between angle 2 and angle 3. They equal angle what? They equal angle 5. All right. So tell me,
Okay, so can you say angle two is greater than angle three?
that's what some people want to say. All we know is that angle 2 plus angle 3 is equal to 5. We don't know which one's bigger, right? Because again, and I totally understand. That's why I'm saying I don't like to look at the figure so much sometimes, because just like down here, you see, I guess what I can try to tell you is, I'll try to draw a triangle and then I can move it around so maybe your eyes can see it a little better. I'm going to make this triangle here, right? Now, do you understand if I switch this way? All right, angle 2 is now bigger than angle 3. Do we agree? But if I go this way, now what? Angle 3 is what? Bigger. You understand what I'm saying, right? As this gets down further, angle 3 gets bigger, right? So just because they decided to stop the triangle somewhere, I don't know the relationship between angle 3 and angle 2. You with me on this? So we don't want to say anything certain about angle 3 and angle 2's relationship. I just know that 3 plus 2 equals 5. And I know that 5 is greater than 3 and 5 is greater than 2. I have no idea what the relationship between 2 and 3 is. They could be equal, right?
Could you go with angle seven is greater than angle three?
For which one? Well, right now, that figure is for questions 3 through 8. Where is this?
Oh, I'm thinking of the wrong triangle the entire time.
That's okay. That's why we were puzzled by you asking for 7 when we don't see a 7 on that figure. All right. Now, all right. So everybody's good with 1 and 2 now, correct?
Yeah.
All right. Let's take a look at measures that are less now 3 through 8. All right. 3 through 8. This is the one that's usually on the test when there's more options for you to have to think about. All right. So measures that are less than angle 1. So now here's what I'm trying to tell people. Angle 1, all right? The reason why it's troubling is because if you need to, you could wipe this segment out right here. Come on, pay attention. And now it's easier to see that angle 1 has to be greater than what? So everybody see what I'm saying, right? But unfortunately, you don't have iPads to do that right now. You just are smart enough to look at that and tell me what's going on. All right, so here, let's go back. The measures that are less than angle 1 is what? Angle 5 and angle 6. We agree with that. Now, measures that we know for sure are greater than angle 1. I'm looking at angle 7. Because 7 is the exterior angle for that. You with me? All right. Now, I can't really say anything about 4's relationship to 7. Do we agree? Right. Even though we can say, you know, one's obtuse, one's acute, but it doesn't matter. All right. It doesn't matter. The only thing you're using is this new theorem. All right. So what number was that?
5.
We just did number 5.
No,
All right. So let's look at the measures are less than angle 7. Angle 3, angle 1, angle 5, and angle 6. And there's one more angle. No, I don't think 4 qualifies. No. Now listen to me. Here's what I'm trying to tell you guys. And I'm not even mad that you're saying angle 2 because angle 7 is obtuse, but just because that's obtuse, does everybody agree I could swing that angle all the way over? Like I could make the triangle look like this. All right, watch. So it makes sense. Right here, I could make the triangle this way and have it come back down this way. Now, this is not greater than this. Does everybody see that? And nothing else has changed. All right. So please, I'm just trying to warn you. All right, we cannot say anything about adjacent angles. We cannot say anything about adjacent angles. Everybody understand that? Although looking at it, 7 is obtuse, 2 is acute, angle 7 is greater than angle 2, but that doesn't have to be the case. I can't say anything about angle 4 either,
Since one is bigger, or since one is equal.
right? You see what I'm saying? I'm not, that's why I'm saying this one is the hard one. This is the one that's usually on the test. All right, angle 7 is definitely greater than angle 3 and angle 1. We didn't have trouble with that. But we also said that angle 7 is greater than 5 and greater than 6, correct? There's one other angle that is missing.
It's greater than 1, here is greater than 4. That's what I thought.
No,
Two.
no.
Well, it's the only two angles left are 1 and 4.
Okay, so you know I'm not,
Oh, 3. You guys didn't see that one?
Angle
U.
V.
angle VUT, right? This right here, this right here, and this right here are the remote interior angles. That's all. I'm not saying you're supposed to see it right off the bat. You're supposed to say, yeah, okay, I see that now. All right. I understand that. That's why I drew it out for you. Angle 7. Look at the yellow triangle that I tried to highlight for you, or whatever that is. This right here, right? Angle 3 and 5, this angle right here is a remote interior. This is a remote interior.
We already said 6.
7 is greater than what? 1, an angle 3, an angle 5, an angle 6. Technically, is 5 a remote interior angle to 7? And the answer would be, of course, what? No, it's not the full angle. But 5 is part of angle TUV, correct? Does everybody agree? 5 is part of TUV. Is TUV a remote interior angle to 7? Yes, therefore 7 is greater than TUV. I said the sum is always greater than the parts. So can we say for certain that angle 5 is less than angle 7? Yes, for certain we can. All right. Now, again, that makes sense to me. I'm not saying it has to make sense to you. I'm saying I want to make it make sense to you. Is anybody not seeing that now? All right. So now one more time. Angle 7 is greater than what angles? 3, 1, 5, 6, and TUV. Very nice. All right. So that was number 5. So now number 6. Measures that are greater than angle 2. So here we go. Let me eliminate this. Cut this out. And now I would hope you would highlight angle 2. So what is greater than angle 2? Please don't say angle 7. Don't say angle 7. Angle 4, definitely.
Because it's the one side. Exterior.
4 is an exterior angle to 2 and 3. Everybody should be able to look at that and say angle 4 is equal to angle 2 plus angle 3. Angle 4 is equal to 2 plus 3. Do we agree with that? Therefore, angle 4 must be greater than angle 2, or 2 must be less than angle 4. I believe that's the only thing I can say there.
5 or 6.
Has nothing to do with 5 or 6. This interior angle has nothing to do with 5 or 6. Anybody have any questions with that? All right, what number are we on now?
7.
Measures that are greater than angle 5. So here we go, hold up. Here is angle 5. So angle 5. Thank you very much. Angle 1 has to be greater than angle 5 and angle 7. And again, like I say, all for the last 2 years, you got to try it on your own. Just writing down angle 1 and angle 7 without putting thought into it is not helpful. And if you don't know, it'd be nice to tell me. Tell me. Say it again. Actually, that's pretty smart. Yep, I like that. You could say it's less than TUV.
Greater than. Oh, yeah, sorry.
That's very good.
What is it?
Well, 5 is a part of TUV. So that was smart. All right, I wasn't really looking for that, but that is definitely true.
Nice job.
What?
So number 6, instead of only angle 4, but couldn't it also be angle 7? And
Okay, so what number you asking me about? Number 6, measures that are greater than angle 2. Now remember what I'm trying to tell you. I don't know. This angle 7 is obtuse, angle 2 is acute. But I could take this UT right here, that is angle 2 right there, and I could make it this way. I can make it less. Do you agree? So that's what I'm saying. Just because the figure looks like that doesn't necessarily mean that it has to be true in all those cases. Do you understand what I'm trying to tell you? So some kids who are literal, right, they look at it and they can only see angle 7 has to be obtuse. That's why I try to demonstrate that just because UT is drawn like that, I can swing that UT over and create the same information. You see what I'm trying to show you? Right? So we're just trying to use the alternate exterior angle theorem, right? And we're trying to demonstrate what angles are greater or less based off that. Now, I did like what Sophia said up here, because 5 is a part of TUV. Therefore, 5 is less than TUV, which was good. All right. Does that help you?
Yeah.
All right. What number are we on now, please?
angle or number 3.
Number 8. All right, let's look at the measures that are less than angle 4. So again, hold on, I like to highlight angle 4 so we can see it better. So angle 4. And what are we looking for? Measures that are less than angle 4.
2, 3.
That's what I come up with, right? 4 is an exterior angle. So 2 and 3, that's really it.
Will you do anything with W?
Can we do anything with W?
What?
No, because W can swing, right? I mean, it's like a vertex, right? That's why I'm trying to show you. If I was, if I would take the time, I could, not that, but now if I put it here, like I can make W this way and this way, like all of the triangle can be redrawn. Do you see what I'm saying? So the only thing that is for sure is this is an exterior angle. So that's got to be greater than those two, right? All right. 9 and 10. All right, take your time. Let's see if you understand what I'm talking about. Measures, don't say it out loud. You try to answer 9 and 10, and then let's see if we can come up with the same answer. Pause the video for a minute, just a second. I'll give you a minute. All right, what are you thinking?
I got.
Hold on, let me write this. I'm listening now. Angle what?
P.
Angle P.
Angle N.
Angle, well, you can't say angle N.
It's 8 and
This is the N right there, correct?
Oh. But another answer I got was angle 6.
Okay, angle 6.
And I thought.
Angle 4.
Well, now, wait a minute. Measures that are less than angle one. Now, angle six, that angle six is part of its own. Correct?
Yeah. And then 7
Whoa,
plus
whoa,
6.
whoa.
6 plus 4 equals 1 plus.
If angle 1.
Yes, thank you very much. Listen, some of you guys, now let's listen, okay? Let's give everybody a shot. Now listen, I'm really trying to get away from, you're allowed to say something wrong, all right? So think about it. I appreciate you thinking it, even if it's wrong, it's better than just not thinking. All right, that's what some of you don't understand. All right, you're not getting any better if you don't learn to just say something. All right. Now, if I were you, I would look closely at 6 and 4. All right. I wish, and I heard someone say it, 6 plus 4 is the same as 1 plus 2. Do you agree with me? But I don't know anything about the relationship between 1 and 2 to say if it's greater or less than. Does everybody understand what I'm saying on that? Right? It can be all different kinds of combinations of numbers. All right. So let's try to systematically go through this. So if when you take your test, to me, there's just, we're talking about angle 1, right? What is the question? I forgot already. What? Less than 1. So I'm highlighting angle 1. That's the exterior. All right. So what, right off the bat, I'm just looking for the remote interior. The remote interior would be angle what?
7.
And hold up, angle 7 and angle NPR or NPO, whatever. That's correct. NPO. Now, NPO is made up of what two angles? So it has to be greater than that. Do we agree? So then we could say angle 4 and angle 5. All right. Now, I'm trying to convince you there's nothing I can say about 6. All right. Now I have this angle broken down. Is there anything else that anybody else put they'd like me to double check? Everybody's good? Whit, tell me.
Is angle NPO, all the angles added up?
5 and 4.
Yes. If
Or
you're,
is it just 5 and 4?
Oh,
it's just 5 and 4.
But did we already say that?
Well, no, you talking about this right here?
Yeah.
They're individual though. Angle 1 is greater than this angle right here, and greater than this angle right here, and greater than the whole angle. You with me on that, right? Right. All right, so let's see what number 10 says. Measures greater than angle 4. So hold up a second. So I gotta clean this off. And now I'm going to look at angle 4. All right. So we already know that it's greater than angle what? 1, do we? Angle, well, yeah, I meant to say that. Yeah, I'm sorry. So
Okay.
angle 1 is greater than angle 4, right? So that's what I meant to say. Angle 1. And then,
NPO.
yeah, I like that. NPO.
Is that like 1 and 2 or 1, 2?
No, that's, there's no angle O, right? It's right. It can be RON, NOQ, QO. There's lots of different things to call that. All right. So hold on one second. All right, I'm going to paste this over here so I can just continuously look at it. All right, measures that are greater than angle 4.
Angle 8.
Definitely angle 8. Thank you. Definitely angle 8. All right. Is there anything else? Sophia, anything else? You caught the last one. Yeah, good.
What about angle?
We don't know for sure.
Right. And again, this is what I'm appreciate these kind of answers. So the nice thing I like about my iPad is because I can put this here and say, I can move this Q higher or lower. You see what I'm saying? And I don't know. That's why you can't say which one's bigger or smaller.
But
If
why-
I move it this way, which one's bigger, 4 or 5? Can I put it somewhere in the middle where they're equal? And I can make it down here where they're, you see what I'm saying, right?
How are we allowed to move the lines of the triangle if there's already a triangle drawn? So what would even be the point of there being a triangle if we can just change all the lines if we want?
Yeah, that's a good question, because I can make this, and this is where I've seen some videos of where I can have this triangle drawn, and just because I draw that triangle, I can still move this. You see what I'm saying? Nothing is changing except the size of the angles.
The
Right.
angles aren't changing.
Yes, the angles are changing. That's the whole demonstration. All right.
But
Just-
everything's changing.
Yes, things are changing, but something remains the same. This angle, regardless of what you do to this triangle here, regardless, angle 1 is staying greater than 5 and staying greater than 4. No matter how you move it, it's always going to be greater, no matter what you do with it. All right. All right, does everybody agree that's really not that hard? All right, hopefully you agree. All right, so let's go down here. All right. Now, here is what I would like to try to demonstrate now, please. Look up here on the board. Look up. All right. So if I'm going to draw a triangle now, right? And as I move, let me say this. Here's A, here's B. All right, please. And again, like I said, I'm trying to be better, but I don't understand why this is difficult. All right. I'm showing you the demonstrations. I feel like it's just obvious, but it's not obvious. And I don't know why. I'm shortening AB. I'm going to call this, and I'm going to put C over here too. I'm going to shorten AB. As I shorten AB, what's changing? Angle C is changing. I tried to move that nice and slow. So I tried to create where B was the only thing. Now is BC changing? The length of BC. All right, wait a minute.
Angle B is also
Wait,
changing.
no,
Well,
it's not.
that's what I'm trying to get people to see. Thank you. It's not, if I do it properly, all right. And let me do this. I'm gonna bring this down here for a second. And then I've been trying to do better at my drawings, so people can see, all right. But for some reason, it's just not working out. So I'm going to highlight something. Maybe I can do it this way. Here, that's a straight line. Does everybody agree? All right, so I'm going to try to move this. And I'm trying to demonstrate, is BC changing? Is the length of BC changing? Okay, so if I create a circle, right, here's what I'm doing. If I create a circle, all right, and this is kind of like, BC is kind of like the radius. It's staying, well, it's staying just right here on this. That BC is not supposed to be changing. That wasn't even a very good representation. But I'm trying to keep BC from changing. All right. So what I'm trying to show you is that angle or side AB is dependent upon what? Is dependent upon what? This angle. Right? The bigger I make this, right? Oh, now it's not working. All right, let me start over. This right here, as I lengthen this, do you see angle C is getting bigger, right? So right now, in your head, what you're supposed to say is, when I open this angle, then the opposite side is getting bigger. So I agree with that. Yeah, and eventually I'll tell you about the hinge theorem. That's exactly correct. So if I'm moving this down, AB is being affected by the angle, correct? And if I move this one, all right, let's say I start over here, then angle C, right? The AB is moving angle C, right? If I'm coming this direction, angle B is changing. AC is changing. Are we with me on that? All right. So believe it or not, the bigger this angle is, the bigger angle B is, the bigger AC becomes. Do we agree with that? The bigger angle A gets, the bigger what? BC gets. Now, I used to say this to kids all the time, but I don't think they understood what I was saying. When I say angle ABC, what's the vertex of angle ABC? B. So if B is changing, what side is changing? AC. And to me, it was easy because B is in the middle of what? AC. So if B is moving, then AC is moving, correct? If C is moving, then AB is moving. It's the opposite side is related to the angle. All right. And I always try to show kids all the time, here's my pencils right here. If I open and close this, you're supposed to see this is changing. That side is changing. As I open the angle, the opposite side is changing. These, do we agree, can remain the same, right? But this is changing with that angle. Agreed. All right. So again, I say this is just so simple. All right. And like I said, I don't know why it's difficult. So if I'm looking down here at question number 11, what side is the largest side? RT is the largest side. So which one has to be the largest angle? S. The shortest side is what? So the smallest angle must be what? That's how easy it is. All right. Like I said, I try to make it obvious, but for some reason, it's not obvious to some people. So it says list the angles and sides in orders from smallest to largest. All right. This is too repetitive. All right. So in this case, the smallest angle is going to be what? Angle T. The smallest or the middle angle would be what? Angle R. And the largest angle is what? And you know what? Even if you don't know the rule, for goodness sakes, you could look at that and say, well, angle S is what? Bigger than all of them. Right? That's the nature of it. All right. Just like on number 12, you have to write the smallest side first. What's the smallest side? SR is the smallest side. That is correct. And then the next smallest side, ST, and then the largest side would be, right. Is everybody with me on that? Yes.
So the sides with the smallest angles make the biggest lines?
So here's what I'm trying to say one more time. The smallest angle is opposite the smallest side. The largest angle is always opposite the largest side. And the converse, if you have the longest side, it's opposite the largest angle. It's always small to large, right? The smallest angle, and this is what I mean by this. So here's something that I think is helpful if you listen. Which one is the smallest angle here? So when I say angle T, the other two letters are the sides. So everybody, come on now, watch what I'm saying. Angle T is the smallest angle, correct? So I can just write RS. Now I'm using angle R is next, correct? So then I know it's just what? ST. Then S. The other two angles are what? RT. So that's just something I don't understand, right? It's not like you have to even know that. But if just identify the smallest angle, T, then just write the other two letters. That's what I'm trying to say. Just like over here, what's the smallest side? AB. So we don't even have to look. We've mentioned 2 out of the 3. So the smallest angle is what?
C.
Does everybody understand what I'm saying? Now, what's the middle side? So it must be what? Angle B, and then angle A. That's exactly it. That's all I got. All right, that's how simple this lesson is. All right, everybody's good with that? All right, so your job, listen, I don't care about finishing that up. That was pretty easy. Oh, they might try to throw you off here by giving you two angles, but of course you have to measure the what? You have to calculate the third angle, so don't let that fool you. All right, I agree. So now please try the practice 1 through 27. That's your job.
You just
All
said
right.
you don't care about finishing that.
You're right, finishing the second page. You're right. You're welcome. If you would like to get the extra practice in, which I'm sure you do, you can finish up the second page also, Audrey.
I'm going to talk to myself.
Okay, you do that.
Oh, Lenny.